Who would like to read this first? Jacob. Once we get to a place that you can have some more time, yes. Jacob.
Or do you want me to read first?
Just that first paragraph.
Okay. In the previous task, finding the gazebo, you developed a strategy for finding the perimeter of a regular polygon with n sides described in a circle of radius r. So Honey's strategy consists of the following formula.
Does that look similar to ours? 2nr sine 360 over 2n. How is it different from ours?
It's
Where
sine over it's 2n instead of just n.
So what was ours in, you're talking about right here, yeah?
And okay. So in ours it was like 180 over the number of sides. This one's 360 over 2n.
Okay, so we reduced it, right? So ours said 180 over n. They're saying the same thing. It's an equivalent statement. We just reduced it a little bit. Okay? Tehani drew this diagram as part of her work that she developed for this formula. Okay? So that looks pretty similar to ours, right? We had the radius over here. We called this op, right? And then the whole side we called like 2 times op. And then we still called the altitude height. Okay? So that's good.
the only thing that was different was the op and 2 op that we had.
Yeah, we just said op and she said X, right? So using Tehani's diagram, explain in detail how she arrived at her formula. Well, there will be a really convenient thing right here where we can say, see previous lesson number 5. Okay, because we went through and did that whole thing, right? We derived this equation.
Yeah, it's not very sharp.
What's not sure.
I mean, it's
The glass side he has.
plexiglass.
What's
Isn't
you do with
it?
the rest of it?
Is it plexiglass?
I think it's real.
That's real glass.
No, it's the fact that you pulled out 2 pieces.
All right,
What did you have?
so we can see the previous lesson. Now, since this is what I'm going to want you to do in just a second, okay, when I leave, this is part of what I want you to do. But not yet. I'm just going to go to the other building. I talked about this. And Mrs. Krause is going to come in here and hang out with you guys.
Enough to share with the whole class?
No, I
And
don't.
don't bring a snack.
I'm hungry.
If you're gonna bring snacks, you have
Eat
to
with
have
them,
enough for the
okay.
whole class.
No.
Bird shares.
You're going to at me right now? You're going to at me. Okay.
That's not the whole question.
So since n is the only thing that varies in this formula, right, because the radius is consistent, we're just saying if we have a different number of sides of the cyclic polygon. N is the only thing that changes in the formula. So what we could do is rewrite the formula to be this right here, where 2r is outside kind of on its own, and we only have to change this. Okay? So what you are going to do is you're going to say, all right, what happens to that n sine of 360 over 2n when I put it into my calculator and when the sides get large, or the number of sides gets larger and larger? Okay? So like right here, what I would want you to put in your calculator is 6 anywhere there's an n. Okay, so 6 times the sine of 360 over 2n. Now you need to make sure that this whole thing, this whole denominator right here, is in parentheses. Otherwise, it will not give you the correct answer.
Wait, what's
The 2n.
Oh,
You need, so this whole thing needs to be in parentheses on your calculators, but this whole thing needs to be in parentheses too. Otherwise, your calculator will misread what you are inputting.
The automatic parentheses that it does for when you can.
You need another set for the denominator beneath 360.
So
set 3.
that's this correct. That's not correct.
Put 2 times 6 into parentheses. So move that parenthesis over.
Okay.
So let me show you what mine looks like real quick.
How are we supposed to do that with
Whoa.
these ones?
Yeah.
Okay.
How are we supposed to do it with these ones? where
So you're gonna have to do-
you have to do that entire in parentheses equation and then sign.
So let's see real quick. I don't think I have one of those.
Here, Mr. Ball, I got you.
Thank you. So what you're going to need to do is you will have to put in here 2n, so 2 times 6, because it's going to get to a space where won't know what it is in your head, right? So you've got 12. Then you're going to have to do, 360 divided by 12, okay? Then you can take sine of that, and then you can multiply it by 6. So you kind of have to work from the inside out when you have calculators like that.
So it's 3 then.
Yep. So that one should be 3.
Put that in blank.
Yep. Okay, so we're going to put a pause on that because you will come back to that and fill the rest of those in. And you can check with each other, but I want you to put those into your calculator. Okay?
And are we doing that while you go get your?
You will do that, but there's a second one as well. Okay? So then you can answer number 3 on your own. And the second one, Tehani is talking about the area of the polygon, right? Can you see how her formula is different than ours was? Mm-hmm. How is it different?
Wait, hers is the same as ours.
There's an extra
You're
step.
you're using both sine and cos. Or no, not
And
no,
we're
because
you're adding
you're just combining them both,
That you guys
basically.
simplified, and so since
Yeah.
instead of 360.
Because you're using your equation for height and then putting it
Okay.
along with your area of the entire thing, which I used
R
on our.
squared.
So we did
Oh,
again,
R squared.
180 over n, and then, oops, not over
And
2.
they have 2 in and we just have it.
Right, so we reduced it, correct? And then what did we do with these r's?
Combine like terms.
We combined like terms. Well, actually, we really multiplied them, right? So r times r became r squared. So, again, we could say, see previous lesson number 5. Okay? And they said, again, since n is the only thing that changes, they isolated r squared out here. And we want to look at this n times sine of 360 over 2n times cosine of 360 over 2n. Okay? This one, you may have to, for those of you that have the calculators that are just the TI, what are they? TI 14, TI 30. Okay? You may just need to write down, like, for this one, 360 over 2n, or over 2 times 6, is equal to 30, okay? So that you can plug 30 in and say cosine of 30 times 30 sine times 6, okay? So you may need to do some work on the actual piece of paper that allows you to then plug that back in, okay?
Mr. Ball, I gotta ask. How did you get the tables and chairs down?
We lifted them down.
And then flip them over.
Yep. No, we did. What? Okay. So this first one then should be 6 times the sine of 30. Close your parentheses times the cosine of 30. And what do you get? Actually, let's go to the...
Yeah, I did 2.59.
Well, it should be 598 because this 8 would round that to 6. So we could even say 60, 2.60.
Okay, yeah.
Yeah.
Because I put 2.598, but then I was like,
The 8 would round the 9 to a 10, but then the 10, so you would have to round it to 0.60. Okay? All right. Any questions on that before? Because now you're going to also answer number 6. Okay. You can check with each other while I'm gone or while Mrs. Krause steps in, and we will talk about this again when I'm back. It's some really exciting
Get
stuff.
closer and closer to a circle.
Oh,
Find
yeah.
the relationship between that diameter and that circumference.
how big would the number have to be for it to
It would have, for it to be exactly pi, you'd have to have. your
No
calculator.
calculator.
So I would change that. I would
So,
change that.
as the number of sides increases, we get closer and closer to pi,
Yeah,
right?
We have like quantum computers or whatever the highest thing is now
Dude,
currently
that hurt.
running.
So what would be then the new formula if this approaches pi? What would this formula now be?
5.
The whole thing would be just pi?
Yep, just 3.14.
False. Incorrect.
But it just,
Would that be
Because we took
just
circumference? Would that be diameter over circumference?
No.
wait, you're finding perimeter, right?
Yes, and so
So
we
where-
were looking at this value. This value approaches pi. So where is that up here in this formula?
So
Wouldn't it just turn into the formula of perimeter of a circle?
Right, yeah. So it would say the perimeter of a circle
No.
is 2 pi r, which we know that to be the formula for circumference, yeah?
I said because it was because we kept the 2r outside of the equation. So then
Exactly.
I was like, I just added pi onto the end. And I was like, my brain didn't switch on.
No, that's fine. That's great. Okay, awesome. Now how about this one? The area for that figure.
Would it be this same? It's the same thing of approaching pi, but then you would just do. It's because it's r squared, so pi at the beginning.
Pi r squared. So the area of a circle is just our area formula, right? Yeah, very nice. So, historically speaking, I know that we take this for granted now because it's something that we just talk about so often, like, oh, the formula for the area of a circle. We just know that, right? But back when, they were first discovering mathematical theories and mathematical facts, this was not always known. So this is the way that they initially could have started figuring out, oh, this is the area of a circle. Because a circle is a weird shape, right? How would you measure the area? Like a rectangle, you can measure the area of that because you can just go one side times the other side. That's the shape. But for a circle, you can't get that measurement. Yeah, it's weird. So you might get you might be able to get the radius and the diameter measurements, but other than that, it's like, okay, how do we find the area? And this is kind of how they discovered pi as well, because they were saying, oh, for a polygon that we put inside of this circle, if I put a square in here, here are the dimensions of it. If I put a pentagon, here are the dimensions. If I keep upping the number of sizes to, say, 10,000 sides, then I get a number like 3.1415 and so on, right? Okay, so you can start coming up with the formula for an area of a circle or the circumference of a circle, the perimeter of the circle, by this approach, okay? Here's another way that they could have done it. The second approach,
Chinese did, didn't they?
I have no idea.
The Chinese love using shape.
Could be.
So did the Greeks.
Okay.
Pi, beta, like,
So a circle can be decomposed into a set of thin concentric rings. So this is where if we built a circle with a whole bunch of rings, and then we went ahead and laid these rings unrolled and stacked on top of each other, what kind of shape do we start seeing?
Staircase.
A staircase?
A
A
triangle.
bar graph.
We also kind of see a triangle, right? And if these rings were thinner and thinner and thinner, we would get closer and closer to a perfect triangular shape. Okay?
It's like sorting algorithms. You ever seen
no.
those?
No.
Seen-
I get
You
easily
need
distracted by
you
those.
need to watch sorting algorithms. They're
Okay.
the best thing.
I'll watch them at some point, but we're going to focus on this right now. So, if we were to look at this, we know how to find the area of a triangle, right? What's the area of a triangle?
One half
Yeah, 1/2 length times width.
times base times height.
Yeah, I'll call it base times height, but it's really the same thing, length times width, either one. Okay, we know that the area of a triangle is 1/2 base times height. Now, what is the formula, or what are those two, base and height, not in regards now to this triangle, but in regards to the circle?
Those are your radius and circumference.
Oh yeah, look at this right here. This radius is actually just the height, right? So we could say instead of radius, or instead of height, we can say radius. Thank you. What about for the base of this circle? What is this whole thing, or the base of this triangle? What is that thing? Yeah, it's the circumference, right? So if we say the height is equal to the radius, and the base is equal to the circumference, which is, what's the formula for circumference, BT dubs?
Pi, it's 2 times, pi diameter. Words are difficult.
2 pi r, right? Which is the same thing as pi times the diameter, yeah. So, there we've got some things here, right? We've got a different way to represent the side and the base of this triangle. And as the rings get smaller and smaller, narrower and narrower, the triangular shape gets closer and closer to being an actual triangle. Now, if that's the case, what does that imply about the formula for the area of a circle relative to the area of a triangle? Like, how could I find the area of this triangle made from this circle? So, okay, let me say this again, or in a different way. The triangle is made from the circle, right? We just unraveled the circle, all the parts of the circle. How then do I find the area of that triangle?
The area.
With your area
Do the
formula.
formula.
Okay, but should I use base and height, or can I use these things right here?
Well, since it's from a circle, you know the dimensions of the circle rather than the triangle.
Exactly.
Yeah.
So I have to use the formula, which is 1/2 base times height. But in circular terms, that's going to be 1/2 the base, which is 2 pi r, times the height, which is r. Now, what is 1/2 times 2?
That's 1.
That's just 1, right? Boo boo. They just cancel off. And then I have pi. And what is r times r?
R squared.
So the area of a circle is...
R squared. Whoa.
Wait, what?
You good, Mr. Ball?
Oh.
No.
We just found out the area of a circle from a triangle. That's
Have you seen the?
lit.
Triangle.
This is kind of off topic, but it involves a circle and it's being cut. It's metal and it just kind of flops.
Oh, yes.
Oh, yeah.
No, I have not seen that.
Really cool looking.
Nice. Okay, here is our third and final approach. Okay, a circle can be decomposed into a set of congruent sectors, as shown on the left in the following diagram.
I thought you were going to take a wrench and I was like, why?
No. Okay, so congruent sectors of this circle. We could rearrange these sectors to approximate a parallelogram, as shown in the figure on the right.
Wait,
Focus in here, you two. Focus in here. Thank you. Okay.
national pride.
If I were to make these sectors smaller and smaller, what kind of shape would I get?
A parallelogram.
I would get a rectangle, right? A special parallelogram.
Your parallelogram special.
If we had more and more sectors, we would get closer and closer to a rectangle. How would we describe the height of that rectangle?
The radius?
Yeah, the height would just be the radius, right? Because we've just stacked them back and forth on top of each other. So the height... Wow, hello. Thank you so much.
Welcome.
I appreciate it.
Hey, happy Teacher Appreciation Week.
Woohoo!
Oh, it's teacher appreciation week.
You didn't
Girls
realize
don't have
that?
school.
It's
No,
in classroom.
I have no idea. Maybe she's the principal for a day. Dude, it's Teacher Appreciation Week
thought that
all
was
week.
for a day.
So just keep it in mind this whole week.
I'm
Feel
gonna be
free
under
to
your bed
appreciate me.
We appreciate
anyway.
you, especially if you let us watch Belly Crafts and Biology.
Thanks, Tayson. Okay, so the height would be the radius, and this is the height right here, yeah? As we got thinner and thinner. What about the base? What would the base of the rectangle be?
Circumference.
Is it the entire circumference?
Well, how?
Wait, why would it only be half?
Because the other half is on top.
So you gotta have half the circumference up here and half the circumference down here.
Down here. You stay over. Jason, you stay over.
Okay, so the base is equal to 1/2 of the circumference. Which, what is the formula for circumference?
Pi diameter.
2 pi r. Let's keep it in terms of r since we're dealing with r.
Oh wow, it's almost like the last equation.
What happens to the 1/2 and the 2?
It goes over, the 2 gets crossed out.
Boo, 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 boo. Okay, So now I've got pi r. So what would the area be? We know that the area of a rectangle is what?
The area of a rectangle should be 360. It's four
Base
sides
times
triangles.
height.
Oh.
That's all I want, right? The area of a rectangle is base times height. So if I have the area of this circle that's been reformed as a rectangle, what again was the base of this rectangle?
That'd be half C.
Half C, which is pi r, right? You guys are like pirates. And what is the height today? You pirate. It's r.
Favorite letter.
That's
You can't get this right.
R
'cause there are two
squared.
answers.
I. Because they only have one.
Either
Well,
the
actually,
C
they have
or
two.
Usually,
They just wear an eye
I
patch.
can't speak.
I know, it's so that when they would go under,
Yeah,
they could
and so they could
take it
just
off and
do
not
that.
be swashbuckled by those pesky people who are trying to protect their ship.
Yeah, well,
I'm
imagine
so happy this is all
trying to
being recorded.
protect property rights.
So,
Yeah.
we get the area of this circle that has been broken down into a whole bunch of small sectors as the area of a rectangle that we have built from those sectors, and that again is pi r squared.
Word.
Word.